In the previous session, we looked at Huffman coding and we introduced an example of how you can apply Huffman coding in such a case. So now we're going to see how you can implement Huffman coding. We're going to start with the pseudocode for implementing Huffman coding so that later on you can implement it in your preferred programming language. But after that, I'm going to be implementing it in Python and you can basically follow along. So before we get into the pseudocode, just as a reminder of what Huffman coding is. So ideally, Huffman coding is a compression algorithm that reduces the size of data by encoding frequently occurring characters with shorter codes. So you can just simply refer to it as a compression algorithm. And apart from that, so it being a compression algorithm, it is used in a number of file compression formats. And one of these file compression formats where it's used is files like formats like zip and JPEG. And how it works, from what you've seen previously, is that it uses a greedy algorithm, of course. It's a greedy algorithm, rather, and it assigns shorter binary codes to more frequent characters and longer codes to less frequent characters. So basically, it outputs an encoded string and a Huffman tree, or basically a decoding map that can be used. Now we're going to jump ahead and look at the pseudocode for this. So this is pseudocode on how you can implement the Huffman coding algorithm. So basically, again, refer to the previous video to get into more detail on how it works. But we're going to have basically a Huffman coding. So let's say this is sort of a function that takes in a text, and this is the text that we're trying to basically compress. So a text file, any of that. And the first step that we go through is we calculate the frequency of each character in the input text. So calculate the frequency of each character in the input text. Now, each character in the input text, we basically check how many times that character appears. After doing that, we're going to go ahead and create a priority queue of leaf nodes. So where we're going to have each node containing a character and a frequency. So we're going to go ahead and create a priority queue, or basically a min heap. And we already looked at min heap and max heap. You can refer to that video to just refresh your knowledge on that. And it basically going to contain leaf nodes, where each leaf node is going to contain character the character and the frequency of that character. And the third thing we're going to do is now we're going to check basically while there is more than one node in the queue. So while more than one node so while there's more than one node in the queue, we're going to do a couple of things here. And the first thing we're going to do is we're going to remove the two nodes that have the smallest frequencies. So basically we're going to remove two nodes with the smallest frequency, or the least frequency. Remember, since the first thing we did is we checked the frequency of each of the character. After doing this, the next step that we're going to go ahead and do is we're going to create a new internal node. So after we remove these two nodes to the new frequency, then create a new internal node. We're going to create a new internal node with a few things here. So to create this new internal node, it's going to have a frequency. So the new internal node is going to have frequency, and where frequency is going to be the sum of the two moved nodes. So remember the two smaller nodes that we had. So we're going to have frequency, which is the sum of the two removed nodes. And after doing that, the next thing we're going to have is we're going to have a left child and a right child. Remember, we're creating a priority queue here. So we're going to have basically a left child and a right child. Left child and the right child. So the left child is going to be the first removed node, and the right child is going to be the second removed node. After doing all this, what we're going to do now finally in this step is we're going to add a new node back to the priority queue. So the new node is going to be, remember, the new node is the sum, or the basically a combination of the two nodes. That's now in terms of their frequency. We're going to add a new node. Add a new node to the add a new node back to the priority queue. So we're going to add the new node back to the priority queue, where now we're going to have this new node and basically the rest of the nodes that are remaining after we had removed the two. Now the fourth step from here is going to be now renaming the root, the node that is basically is the root of the Huffman, or the remaining node of the tree is the Huffman tree, that is. So the remaining node is the root of the Huffman tree. Just to repeat on this, so remember this step here, this third step will always continue until we've basically gone through all the nodes that are there, and at the end we're going to have a final node, which is going to be basically a combination of whatever previous two nodes that are remaining. And now this final node that we're going to have will be the remaining node, and that will be at the root of the Huffman tree. So an example of basically the root that we created in the previous section, this 100, which will be basically node A, B, C, D, this is now the root of, that's the root of the Huffman tree. And after this, what we're going to do is we're going to create binary codes for each character. So remember, once you've created the tree, it doesn't end there. So we're going to generate binary codes. Generate binary codes for each character. And how we generate these binary codes for each character, we do that by traversing the tree. By traversing the tree. Now, in terms of how to traverse a tree, we've also covered this previously. You can basically go refer to that on how to traverse a tree. So basically, we're going to assign the binary codes to each. So the left edge is going to be the left edge. We're going to give it a 0. And the right edge, we're going to give it 1. So we've assigned, by doing this, we've assigned binary codes. We've assigned binary codes to each. Now, the next thing we're going to do is we're going to encode the input text using this generated binary codes. So encode input text using the generated binary codes. So how this happens, basically, just referring to the previous, the example from the previous video is, if we have basically, let's say A is the one that we want to represent. Remember, we're saying we're encoding the input text using the generated binary codes. So each edge has a binary code, and if you want to generate basically a code for A, we're going to check how many does it take to get to the root of the tree. So it is 0, 0, 1. Now 0, 0, 1 is going to be the code for A, and we do the same for all the others. And finally, we're going to basically return an encoded string with all these codes. We're going to return a should be a U here. We're going to return the encoded string and the Huffman tree for decoding, basically. The Huffman tree for decoding. So basically, this is the entire pseudocode for implementing the Huffman coding algorithm. You're given a series of characters, so you're given a text, and then the first thing you need to do, we do is we check the frequency of each of the characters. Then we're going to go ahead and simply going to implement a Huffman tree. We're going not Huffman tree rather, but we're going to implement a priority queue. We're going to start by checking the first two list or rather characters with the smallest frequency. Then after we combine the two and generate a node, so that node we generate is this one, in this case AB, and we're going to return check this back to the priority queue. Then we go ahead and look at the next list, the next basically the least frequent characters, which is going to be AB with 25 and C with 30 in this previous example here. And the process is going to proceed like that until we get to the root, which is where the remaining node is the root of the Huffman tree. Now that we've seen the pseudocode for this, and I hope this should be Huffman, so it should be a U here. Now that we've seen how you can implement the Huffman coding algorithm in pseudocode, let's go ahead and look at the implementation of this in Python.